Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.3, Problem 11. This is Section 12.3, Problem number 11. It says find the derivative of f of x equals, and we have a fraction or a quotient. The top of the quotient is 2x plus 9, and the bottom or denominator is x squared plus 2 in parentheses raised to the 5th power. So quotients are usually represented with a u for the top or numerator and a v for the bottom or denominator. And now if you remember the quotient rule from the previous section, section 12.2, the quotient rule says the derivative f prime of x is vu prime minus uv prime over v squared. Now, as we fill this in, the u prime or derivative of the top will be easy. The v prime or derivative of the denominator will require the chain rule. So as I fill in this quotient rule, the v can stay a v, the u prime can stay u prime, minus will stay a minus, the u will stay u. Now where I have v prime, I'm going to apply the chain rule because the v is really stuff in parentheses to a power. So the n is going to come down in front. I'm going to leave the stuff in parentheses the way it is. I'm going to reduce the power by 1 and then multiply times stuff prime. And then I'll still have that v squared in the denominator. So let's go ahead and fill that in. F prime of x equals. So we start with a v, which is just the denominator, no prime, which is x squared plus 2 in parentheses raised to the 5th power. Then times u prime. So u is the numerator 2x plus 9. U prime is just 2. Again, the 2 comes from the derivative of 2x. Since it's just an x to the first, the derivative is the number in front of the x, which is a 2. The 9 has no x with it. Its derivative is 0. So now I'm at the point of the formula where I have that minus written. And then I have u, no prime, just u. So u the top is 2x plus 9. And now for the v prime, I have to apply the quotient rule. Because the v, or denominator, really is some stuff in parentheses to a power. So to make a v prime, I need to apply the quotient rule, the chain rule, bring the n down in front. So we're going to start with a 5. Let me put this in brackets just to be clear that the whole thing is multiplied times the 2x plus 9 in front. So the 5 comes down as the n. Then we leave the stuff as it is. X squared plus 2 is the stuff. It stays x squared plus 2. It's in parentheses. My new exponent is n minus 1. So the n was 5. N minus 5. 5 minus 1 becomes a 4. Then stuff prime. So the stuff in this case is x squared plus 2. That's the stuff. So stuff prime, the x squared has a derivative of 2x to the first. Now again, why is the derivative 2x to the first? It's the exponent of 2 that comes down times the number in front, which is not written but understood to be 1. So the exponent of 2 times the number in front of 1, 2 times 1 is 2. X to 1 less power, so second power drops down to a first power. The 2 on the end has a derivative of 0 because there's no x with it. So I can close up the parentheses. The derivative of x squared plus 2 is just simply 2x. And then the denominator squared, v squared. So I'm going to have x squared plus 2 to the 5th power. And that whole thing, including the 5th power, will be put into brackets and raised to the 2nd power. And if you do want to simplify it, you can just make that a 10th power. So now that can be simplified if you want to Is it worth it? I guess we can clean it up a little bit. So I'm going to do, and you don't have to. From this point forward, it's optional. Up to this point is the calculus. Beyond that is algebra. So there's not that much you can do with the x squared plus 2 in parentheses to the 5th power times 2. So I suppose we can write the 2 in front. So 2 times x squared plus 2 to the 5th power. Now I have a minus, and then I have an x squared plus 2 in parentheses to the 4th. So let me leave a little bit of a space, and I'll write x squared plus 2 in parentheses to the 4th power. Now, a lot of other things are being multiplied times that. I basically have a 5 times 2x is 10x, and that 10x is being multiplied times the 2x plus 9 in front. So 10x times 2x is 20x squared. And now for the sign, because of the minus in front, that's being subtracted. Well, let's do this. Let's make some parentheses so I don't lose that negative. And then 10x times 9 is 90x. So, and I still have x squared plus 2 in the bottom raised to the 5th power to the 2nd power. So let me just make that 10th power. So when you have a power to a power, you multiply the exponents. Now, notice in the numerator, I have x squared plus 2 showing up in both pieces that are separated by a minus. So I can factor out as much as a 4th power if I want to clean it up a little bit. So f prime of x equals x squared plus 2. And I'm going to take out to the 4th power because I have up to 4th power in every piece in the numerator. And let me set that off what's left with some brackets. So from the first piece, the 2 is still there, times x squared plus 2, just to the 4th, because when you take out a 4th power and you add a 5th power, this is going to be 1st power. And now minus 20x squared plus 90x over x squared plus 2 to the 10th power. So now when you have an x squared plus 2 to the 4th and x squared plus 2 to the 10th, I can reduce those. This 4th power, x squared plus 2 will go away completely. The denominator will go down to a 6th power. 4 is subtracted away from 10. So now f prime of x is, so what's left after I do that cancellation? What I have here, the 2 times x squared plus 2, I can clear those parentheses. 2 times x squared is 2x squared. 2 times 2 is 4. And then I'm going to subtract minus 20x squared. And because of the minus in front, it's going to be minus 90x over, in the denominator, x squared plus 2 in parentheses to the 6th power. And the last thing you can do is have a 2x squared and a negative 20x squared. I can combine those for a final answer if you want to simplify it to the end. So positive 2x squared, negative 20x squared is negative 18x squared. And then minus 90x, so no other x's to combine with that. Minus 90x, and then plus 4. And then in the denominator, x squared plus 2 in parentheses to the 6th power. So you can clean it up quite a bit. You don't have to. What would you ever have to do with this answer is put in a value for x. So they might say this is a derivative, find the derivative when x is, say, negative 2. So wherever you have an x, you could put in a negative 2, do the math. from this point. You don't have to take it all the way to the end. If you want to, the final most simplified answer is f prime of x equals, you have a fraction in the top, negative 18x squared minus 90x plus 4, and then in the denominator, x squared plus 2 in parentheses raised to the 6th power.